Hello everyone, welcome to the physics class. Today we are going to start a new topic known as atoms. Okay, so topic name is atoms. We know that the whole world is made up of matter, and matter is made up of group of atoms. Then what is atom? Atom is a smallest particle which we cannot divide it further. That is called atom. Correct? And we also know the structure of atom. How the structure of the atom is? The structure of the atom is consist of a central part. This is the central part of the nucleus atom, that is called nucleus, where in the nucleus protons plus neutrons present. Correct? Then outside this nucleus there will be some orbits. These are called circular orbits. In this orbits electrons present. In the first orbit 2 electrons will be present. In the second orbit 8 electrons will be present. And in the third orbit 18 electrons will be present, and so on, like that. Correct? So this is the structure of atom, right? Then what we are going to study in this atoms, apart from the structure of the atom, we are also going to study in this chapter atomic model. What is atomic model? And this atomic model helps us to understand some of the facts or some concepts which we are going to study in this topics. Those are some of the facts are, the first one is stability of an atom. Stability of an atom. You know the atom is said to be stable, right? We are using these words. Why it is said to be stable, when it is said to be stable, that is we have to study. Second one, electrical neutrality. Electrical neutrality of an atom. Sometimes atom is neutral. Atom is said to be neutral. Why? We have to understand here. The third fact is origin of spectral lines. Origin of spectral lines. What are these spectral lines? When these are produced? Why they are producing? All these we'll study in this chapter. Right? So to understand this one, as I said, atomic model is so important, right? Then what is atomic model? Atomic model. Model means you know something like particularly describe something, some information will be given, right? That is called some model, right? So here atomic model means what? Atomic model is the one which describes the constituents of nucleus and its structure, right? So what is atomic model? Atomic model is one which describes what? Describes the constituents of an atom and structure of an atom. तो ये एटॉमिक मॉडल हमें क्या बताता है? एटॉमिक मॉडल जो है वो डिस्क्राइब करता है कि इस एटम्स में क्या क्या है, यानी कि न्यूक्लियस है, इलेक्ट्रॉन्स कहाँ पे है, ये सारा इंफॉर्मेशन ये देता है और इसका स्ट्रक्चर कैसा है ये हमें बताता है, उसे बोलते हैं एटॉमिक मॉडल. तो फर्स्ट टाइम किसने बताया ये एटॉमिक मॉडल और किसने एटॉमिक मॉडल बनाया? The first person who is going to be form an atomic model, his name is Rutherford. What is his name? Rutherford. Okay, he's a scientist. He described or developed one, started doing the atomic model on atoms. Okay. Now later, this Rutherford conducted an experiment which is called Rutherford's experiment, or it is also called as Geiger-Marsden experiment. What is there in that experiment and why we have to study that experiment, we'll see now. Okay, so I'll revise this one whatever I explained now. So our chapter name is atoms. So, we know that what is the definition of atom. Atom is the smallest particle which we cannot divide it further. So this is the structure of an atom. The center part of the atom known as nucleus, where protons and neutrons present, and surrounding the nucleus there is a circular orbits are there. In that orbits electrons are present. This is the structure of an atom, and in this chapter we are going to study stability of an atom, why the atom is stable, electrical neutrality, when we say that atom is a neutral, and the third one is origin of spectral lines, why the spectral lines originates. Okay, that we'll study. The next one, atomic model. What is atomic model? Atomic model is the one which describes the constituents of an atom and its structure of an atom. Then who is the first person who started developing the atomic model? The first person is called Rutherford. He conducted one experiment. It is also called as Geiger-Marsden experiment. Now let us see that what is that experiment and what are the observations of that experiment. Yes. Rutherford experiment or Geiger-Marsden experiment. Geiger and Marsden are the name of the scientists who working under Rutherford. Okay, these are the lab assistant people who are working under the Rutherfords. Rutherfords guide these people to conduct an experiment. What is that experiment? So that experiment consists of source of alpha particle. Source of alpha particle. That is this one. I'll assume that this is a source of alpha particle. Here, source of alpha particle, you may take any radioactive substance. Through that alpha decay, if you do that, then the alpha particles will be emitted due to radioactive substance. Then we'll consider one thin lead slit. This is a lead slit. Why it is used? Okay, so here the alpha particles will be emitted in all the directions. This lead slit will absorb all other alpha particles which are emitted, and it allows only a narrow beam of alpha particles. From here, a narrow beam of alpha particle pass through this lead slit. Then it forms a beam of alpha particle. Now this beam of alpha particle should be made to fall on the thin gold foil. I will repeat one more time, but what material we are using here? Thin gold foil we are using. And what is the thickness of this one? We said that it's a very thin. How much thickness is there? The thickness is said to be around 2.1 into 10 to the power of -7 meters. Such a very small thin gold foil we are using. And what happens after incidenting on the thin gold foil? The alpha particle will start scattering. Right? They start scattering. When they scatter, we have to find out how it has to be incident on some screen. Correct? So here some screen is used. This screen is made up of zinc sulfide screen. It is made up of zinc sulfide screen, and it also has some moving detector, and it consists of a detector, and it consists of a microscope. Okay, so which is movable. Okay, which is movable. Where it is movable, it will be movable on the zinc sulfide screen. What happens? See, as I said, beam of alpha particle which is made to fall on a thin gold foil, then it will scatter. How it will scatter? How it will be scattering? Is it almost all the particles will scatter? No. Most of the alpha particle will not scatter. They will move a straight line. They will move straight line and hit to the screen. And how many alpha particles will deviate or deflect or scatter? We can say that. So only, for example, here only 0.14%. See here, what and it is very important. Whatever the beam of alpha particle falls on a thin gold foil, most of alpha particle move undeviatedly, or they without deviation they travel through straight line and hit to the zinc sulfide screen. But only see here, my word, just you understand the importance of this one. 0.14% of that incident alpha particle deviate greater than 1 degree. Greater than 1 degree. They deviate, they scatter by the angle of 1 degree. How much? Only 0.14% of incident. Now, here 1 in 8,000 alpha particles, that is 1 alpha particle in 8,000 alpha particle will deviate more than 90 degree. How much? Only 1 particle in 8,000 incident alpha particle will scatter or will deviate more than 90 degree. One more thing is there here, that is the only 1 particle here, 1 in 20,000, 1 in 20,000 particles will get reflected back in the same direction, reflected back, which will be repelled back in the same particle. So this is the complete experiment of Geiger-Marsden experiment. Okay, and here how you come to know that here after moving this movable detector, where you find out how you come to know that here only the alpha particles have been scattered, here they are not scattering, here again they are scattering. How do you find out? To find out that, we have a movable detector. When they these alpha particle falls on the thin gold foil, they incident on a zinc sulfide screen. They produces here at particular angles, they produces bright flashes. What they produces? Bright flashes. And then we come to know that there is some scattering of alpha particles have been done. This whole apparatus is placed in a evacuated chamber glass because it should not alter the scattering angle by the air particles. That's why this whole apparatus is kept in a vacuum or a airless chamber. Right? This is a Geiger-Marsden experiment. Guys, I'm going to repeat it one more time in a short manner. Just try to understand. So this is called Rutherford experiment or Geiger-Marsden experiment. Here we are considering source of alpha particle. When this alpha particle will be emitted using the radioactive substance, any radioactive substance, then those alpha particles should be passed through the lead slit such that it forms a one collimated beam of alpha particle or narrow beam of alpha particle that should be made to fall on thin gold foil whose thickness is 2.1 into 10 to the power of -7 meter. Then after falling on the thin gold foil, most of the alpha particle moves in the straight line without deviation and it incident on the zinc sulfide screen by producing the bright flashes. Only 0.14% deviate more than 1 degree and one particle in 8,000 alpha particles deviate greater than 90 degree and only one particle in 20,000 will get reflected back in the same path as it incident. This is the experiment which conducted by the Geiger and Marsden experiment, right? Yes. After conducting this experiment, some observations have to be noted down. Those observations are: most of alpha particles pass along straight line through gold foil, as we have seen in the experiment. Second one, only about 0.14% of the incident particle deflected by more than 1 degree. About 1 in 8,000 alpha particle deflected by greater than 90 degree, and about 1 in 20,000 alpha particles repelled back in the same path as it is incident. These are the observations observed by the Rutherford experiment or Geiger-Marsden experiment. Yes, after conducting the Geiger-Marsden experiment, the conclusion of that Rutherford experiment is what? What they concluded. So after conduction of this experiment and of these observations noted down, later the Rutherford argued that, right? What? Rutherford argued. What he argued? The fourth point you remember. What is that? 1 in 20,000 particles, alpha particles, 1 alpha particle will get reflected back. Why it has to reflected back, or why it has to repelled back in the same path? Why it has to repel? This is a very important concept here. So we can see that we can zoom that experiment here and we can understand that. So I will draw these straight lines are the beam of alpha particles. All these are beam of alpha particles, and this is a thin gold foil. This is a thin gold foil, and we made to fall on them here somewhere at point here. It is incidenting, correct? So I will draw here at some places. Okay, a small point I will consider here. So see this one. I will give the name for the each alpha particle. Here this is the first particle, second alpha particle, third alpha particle, fourth alpha particle, fifth alpha particle, and like so on, right? The first one is very far away from the incident point, where we have taken the incident point in the experiment. There I am considering here. So which is very far, hence it will not be deviated, it will move in the straight line. The second one, which is little bit nearer to the compared to first one, second one is near to the point of incidence, such that it has a small deviation here. So I'll write here a small deviation should be there in the second one. Third one, which is very nearer to the incident point, hence it will deviate more, still more. The fourth one deviate a very large angle. The fifth one just reflected back, right? So here it is very important here. So if I consider this is alpha particle which is moving towards the gold foil and it incident at this point, means this is one particle which is reflecting back. This is a reflecting back, right? Why it has to reflect back? First of all, we should understand alpha particles are positively charged particle. Alpha particles are what? Positively charged particle. And if positive charge have to be repelled back, then here at the point of incident there also some positive charge must be there. Please note down it very carefully. Alpha particles coming here and it is reflected back or repelled back. That means at the point of incidence on the gold foil also there must be positive charge only. This is very important. Here it is positive charge only. That's why this alpha particle will be repelled in the same path. Understand? So this is important, right? From this only he concluded that yes, there is a one point is where a large amount of mass concentrated and it must be a positive charge. Here large amount of mass, and that is mass of positive charge should be there. Positive charge should be there. If this is condition true, then only this alpha particle will be repelled back. So that's why he said that in an atom, the central part is there, which is large amount of positive charges present, and whole mass is concentrated at the center only. This is the conclusion of Rutherford experiment, right? So this is called, this only Newton named this one as nucleus. Nucleus. In the nucleus, which kind of charge present? Positive charge present. So conclusion of this experiment is what? In an atom, central part is called nucleus where positive charge present. We can give the justification using this experiment. This is the conclusion of Rutherford experiment. If you didn't understand, still one more time I'll explain this one in a very short sentences. Conclusion of Rutherford experiment. Rutherford argued that if alpha particle, one alpha particle in 20,000 particles will be getting reflected back or repelled back in the same path, then at the point of incidence there must be a very large amount of positive charge and its mass must be present, then only this alpha particle will be get repelled back. Then this central part, large amount of mass and positive charge, that is called nucleus. This is the conclusion of Rutherford experiment. Yes, after developing that atomic model, conducting experiment of Rutherford experiment, he made one atomic model. Mr. Rutherford made one atomic model. It is also called as planetary model or Rutherford's planetary model. See, what are the postulates of this atomic model? We'll see that. The first postulate is an atom consists of positively charged core called nucleus. जो रुदरफोर्ड एक्सपेरिमेंट किया उसके बाद में उसका जो आर्ग्यूमेंट करके उसने बताया कि अगर अल्फा पार्टिकल रिपेल हो रहा है तो वहाँ पॉजिटिवली चार्ज और ज़्यादा से ज़्यादा मास कॉन्सेंट्रेट हुआ रहता है, उसको क्या बोलते हैं हम लोग? पॉजिटिवली चार्ज को, दैट इज कॉल्ड न्यूक्लियस. पॉजिटिवली चार्ज को इज कॉल्ड न्यूक्लियस. राइट, दिस इज द फर्स्ट postulate. Second postulate, all the positive charge and almost entire mass of an atom is concentrated in the nucleus only. अगर जब भी हम मास ऑफ द न्यूक्लियस ले रहे हैं और मास ऑफ द एटम ले रहे हैं, ज्यादा से ज्यादा मास ऑफ एन एटम कंस्टिट्यूटेड बाय द पॉजिटिव चार्ज ओनली. ओके, क्योंकि वो न्यूक्लियस पे रहते हैं. बाकी जो इलेक्ट्रॉन जो है वो आउटसाइड रहते हैं और इलेक्ट्रॉन, मास ऑफ इलेक्ट्रॉन बहुत कम होता है, इसलिए उसका मास हम लोग नेग्लेक्ट कर लेते हैं. और ज़्यादा से ज़्यादा एटम का मास कहाँ पे कॉन्सेंट्रेट हुआ रहता है? एटम का मास जो भी एंटायर मास है वो कॉन्सेंट्रेटेड इन द न्यूक्लियस पे हुआ रहता है. राइट. देन थर्ड पोस्टुलेट, द न्यूक्लियस इज सराउंडेड बाय नंबर ऑफ इलेक्ट्रॉन्स. राइट, वी हैव सीन द स्ट्रक्चर ऑफ एन एटम. Right, the central part is nucleus and the surrounding the orbits are there. In the circular orbits, electrons are present. That is, the nucleus is surrounded by a number of electrons, and these electrons revolving around the nucleus, similar to the planets revolving around the sun. Our solar system is how the sun is at the center and all the planets are revolving around the sun. In the same manner, here the nucleus is at the center and all the electrons are revolving around the sun. Next, fourth one, the order of the size of the nucleus is 10 raised to minus 15 meter. See, this is very important. 10 raised to minus 15 meter. What is that? The order of the size of the nucleus is 10 raised to minus 15 meter. And the order of the size of the atom is 10 raised to minus 10 meter. So, in this given two data, which one is greater? That is, an atom is 10 raised to 5 times. Remember here, the atom is 10 raised to 5 times greater than that nucleus. Right? So that's why this indicates that what? There is a lot of space, empty space in the atom. So you can see here, I can explain this one. So this is a nucleus and these are orbits. Correct? That means between nucleus and orbits there will be this is one complete atom. Right? This is whole and soul is called as what? Atom. In this atom, the size of the nucleus is how much? 10 raised to minus 15 meter. The size of the atom is how much? 10 raised to minus 10 meter. That means the size of the atom is too bigger than the size of the nucleus. Hence there is a lot of empty spaces will be there here. These are called empty spaces. Right? That is, this is nothing but what? This is 10 raised to minus 15 meter and 10 raised to minus 10 meter will indicate that there is a lot of empty space in an atom. So still there are two postulates are there that we'll discuss in here. Yes, 4 points we have seen that. The fifth one is the total charge on the nucleus is equal to the total negative charge on the electrons. Hence, the atom is said to be electrically neutral. As I said that in an atom, the number of positive charges must be equal to number of negative charges. Then only atom is said to be electrically neutral. Rutherford also says that the same thing. Whatever the total number of positive charge present in the nucleus, the same number of electrons also present in the circular orbits. He said that the atom is said to be electrically neutral. Then sixth one is the electrostatic force of attraction between the nucleus and electrons provides necessary centripetal force. What do you mean by this one? Here, as he is telling that the fifth one is there. Okay, not fifth one. Fourth one. The postulates of fourth one. What is that? The number of electrons revolving around the nucleus, like all the planets revolving around the sun. Correct? Like that. Here, this is the central part, nucleus, and these are orbits. Correct? So this is orbit. This is nucleus, which is positively charged. Correct? Nucleus is positively charged, and electrons are negatively charged. And all these electrons are revolving in a circular orbit. If we know that anything which is moving in a circular orbit, there must be centripetal force. That means these electrons exerting some centripetal force to rotate around the nucleus in a circular manner. One more time I will repeat. If anything rotating in a circular orbit, it must experience a centripetal force. Here electrons are revolving around the nucleus in a circular manner means it must, which one? Electrons must experience a centripetal force. That centripetal force is provided by whom? Who will provide that centripetal force? वो centripetal force कौन provide करेगा? न्यूक्लियस क्या है? पॉजिटिव है. इलेक्ट्रॉन क्या है? नेगेटिव चार्ज है. तो एक पॉजिटिव और नेगेटिव चार्ज होने की वजह से वहां पे क्या होता है? इलेक्ट्रोस्टैटिक फोर्स होता है. जो ये नेसेसरी सेंट्रिपिटल फोर्स चाहिए ना, वो कौन प्रोवाइड करता है? नेसेसरी electrostatic force between positive charge of the nucleus and negative charge of the electron. This positive and negative, that electrostatic force of attraction provides the necessary centripetal force for the electron to revolve around the nucleus. Correct? This is a atomic model. Thank you. Here I will end with the part 1. So part 2 I will discuss in the next class. Thank you.